We have another one of our keynote speakers. There were four keynote talks this. I was going to say weekend, but we are here in the
During the week.
early week. We're so fortunate to have Dr. Jennifer Sucre, an associate professor of pediatrics and cell and developmental biology at Vanderbilt University Medical Center, with an established research program focused on understanding the molecular mechanisms of normal lung development and lung disease across the lifespan, with a particular focus on bronchopulmonary dysplasia, the leading complication in survivors of preterm birth. And I noticed that your lab has a very cool name, the Bold Center.
Yeah. So the Bold Center is more than just my lab. It's a center that we established at Vanderbilt in February of 2024, and it stands for Biodevelopmental Origins of Lung Disease. So within that center, we have partners from adult medicine, imaging, informatics, really bringing people together across campus to think about lung development and how that impacts both in the neonatal period and then
Beyond.
well beyond, well into adulthood.
And I thought your talk, your slides really capture what we sense sometimes at the bedside. Your second slide was called A Tale of Two Babies. So why, when a baby's born at the same gestational age, can they have very different outcomes? And this was part of your discussion about lung organogenesis and morphogenesis. So tell us why.
Yeah, so that Tale of Two Babies plays two roles in the talk, and really for me, that's actually a true story. So when I was a fellow at UCLA, there was one call night where I admitted two babies around the same gestational age, around 28 weeks, basically the same prenatal history. One baby did very well, went home before his due date, is memorable just by comparison with the other baby who had a terribly long course, intubated through 36 weeks, went home on significant oxygen, had severe BPD with pulmonary hypertension. And I don't have a background in basic science. So I had 0 basic science publications before I started fellowship. So for me, my path to science really came from the bedside. And
Love that.
once someone said to me, Janet, it seems like it always has to make sense to you. And I think they were trying to be insulting, but it kind of does.
I was like, yes.
I was like, yeah, it should. And so this idea that there was a lot we still didn't know.
Yeah.
But I've come back around to thinking about those two babies because we've worked really hard to model the permanent deficits and severe pulmonary hypertension in mice. And I say we've worked really hard because I noticed when we had this very long summer of how do we want to model BPD in a mouse, prolonged oxygen and long periods doesn't really resemble what we do at the bedside anymore. So we had this very long summer of 2020 when we were trying to model this. And years later, I was looking at this data and I realized that neonatal mice, unlike human infants, they have incredible resilience. And so this idea of rather than trying to make the mouse like the babies, maybe we should make the babies like the mice. So we now have two.
Mind blown.
We now have two injury models.
Yeah.
One where the mice have the permanent deficits of BPD, and the other where the mice recover. And by looking at non-injured, reversible injury and permanent injury, we can by deduction then figure out what's making the mice recover.
Even when we're trying to make them sick.
Exactly. So what's making the mice recover? And the idea in a really simplistic way is if we could give that to a baby who's born early at risk for BPD, that would be the idea. And we see this already, right, in our unit. We often focus on pathology because as physicians, that's what we're trained to see, look for abnormal and treat the abnormal. And we often focus on the 32-weeker who has very bad lung disease. But the 24-weeker without lung disease should be just as compelling. It's not just we just have really good ventilator tactics.
Right.
We use the same ventilator tactics on every baby. So training ourselves to look for the resilience, both in humans, but also really in mice. So in our research program, we have a biobank of human tissues and human specimens. We have these multiple models. And so that's what we're really studying, is trying to figure out what are those things that drive those self-fate decisions to repair, and how do we drive that?
I love that. I'm a resilience researcher, and this notion of understanding the resilience, individual, structural, and then replicating it is just so compelling to me.
I will say, as a side note, as someone whose lab has doubled in size in the last 3 years, studying resilience attracts the most amazing humans. So there's a way where
How do you market that when you're looking for, like, say, a lab tech?
we just say what we study,
Yeah.
and we find amazing students. We mentor students at all levels. So we have high school students, undergrads, med students, postdocs, fellows. But there is something special about looking for the good. I say that we're treasure hunters. And so there is a way that the humans that we've been able to come do this with us are just extraordinary.
I love that concept because I think in general, medicine says, okay, what's different about the sickest patients? But we should be saying
focus on illness.
sometimes what is special about the babies who should be the sickest and aren't, what is protective for them. I love that. So what do we know?
What do we know? So there's a lot that we know, really from our patients. So there's a couple of things. One of the big findings that's come from our lab in the last few years is how the lung really forms. So we had an idea that seemed crazy 8 years ago. Now seems like just what we do every day, but we wanted to watch the lung form in real time.
Cool.
Because all of the way that we've looked at the lung is just in 2D sections. And when you look at something in 2 dimensions, you can often have artifact or inference. We weren't trying to table flip on lung development, but what happened is that we made precision cut lung slices. We can watch them in real time with a very special microscope that's with partnership from Brian Millis, one of the associate directors of our center. And we can watch the lung form over a 3-day period. What we found is that we don't see ingrowing septation, which is what we've always seen in textbooks. And we think that because when you cut the lung in cross section, you see air spaces with projection. So what we found is that that the lung forms, there are these rings of mesenchyme that provide support, and the epithelial cells aggregate and blow through like bubble gum. They form like soap bubbles to form. And so why that matters, right, is that it changes the questions you're asking. So if you think that you're looking for a magical tip cell that's going to grow in, if that's not what's really happening, you have to look for a different process. So what we found is that the epithelial cells and the endothelial cells find each other to form a gas exchange unit.
And this is in mice who are healthy.
This is in mice who are healthy.
Okay.
So I'm going to put that's sort of like one brick in the wall we're going to climb together. So the next part is that we have a human infant lung repository of babies who have died, whose families let us use a piece for tissue. And we've done some single cell transcriptomics where we try to understand what's happening. And we looked at babies who had severe BPD without pulmonary hypertension, BPD with pulmonary hypertension, preterm infants, and term infants. And the long story short, so this is a publication led by someone who started in our lab as an RA, and his name's Shayan Shirazi. He's brilliant, and he is now a graduate student. But what we found is that the capillaries had some abnormal cells, and he was looking to see, well, what are they making? And again, this is the way we always think, oh, there's the bad guy cell. He must be making bad guy things. We're going to find that. And he didn't find anything. And I said, well, what if we flip it? What if they're not getting enough of something? So capillaries are really more receivers of signal than senders. And so this pathway came up, and it's called semaphorins. So as a mom of teenagers who've been taking the ACT, I will tell you semaphore is like a lighthouse or a beacon.
It's like
a very good.
Yeah.
It's a very good
light.
ACT word, right? So semaphores or beacons. Semaphorins are really well described in the nerves because it's how cells find each other. So we found that they're missing semaphorins. And I won't take you through all of it, but through a lot of very mechanistic experiments and some other new mouse data we see that in reversible injury, semaphorins are revved up.
So in those resilient
They have to find,
tissues.
and in normal development, there's a lot of semaphorin signaling. Once you cross the threshold to permanent injury, or in the most severe BPD-PH or severe BPD, you lose that signaling. And when we take away the receptor for semaphorins in the capillaries in mice, which is, I know baby humans are much more adorable than baby mice, but the mouse you've been making for a year and a half is very special to me. So
Sure.
we made a very special mouse where we've lost the semaphorin receptor in the capillaries. And when we put that mouse in reversible injury, it doesn't repair. So this is this exciting idea that it's the guidance cues. But it all
That's-
came from figuring out, having a model or a mental model of what we thought made sense.
Mm.
So from those movies, it changed our questions. And then really, I say the path to finding out how BPD happens and how to stop it comes from our patients.
Mhm.
The answer is all around us, really,
Mm.
all the time. So
I love that.
I love that because you have this series that I think Dr. Sucre had been on before, Bench to Bedside.
Mhm.
But you're really telling us a story of bedside to bench.
Yeah,
it's
and
bedside
how
to
that-
bench.
Yeah.
I love that. I have two questions. One, where can we watch time-lapse movies of the lung growing? I would like to do that. And the second is, then how do we give babies semaphorins back?
So the second part is we're working on that part. So that's the
Okay.
next big research grant and part of our. There's lots of ways to think about giving them. You would want to give it in a the idea is there's a window of recovery. So why I think of the semaphorins as they're the dinner party host for the cells.
Mhm.
They bring the cells together so that they can have their communications with BMP, Wnt, FGF, all the ways that cells talk to each other. All of those pathways require proximity.
Mm.
So you just
They need their community.
they need someone to send out the invitation. Come
Love
to
it.
the table, and then cells whisper.
It
They
makes plenty of sense.
Wisp.
It makes
They
plenty of
they don't
sense.
shout BMP from the rooftop, right?
Yeah.
There's not a bullhorn. So the idea is you would have some window of recovery when you could right the ship. It doesn't have to be a lifelong
Mm.
situation. You can watch movies most easily. JCI Insight, which published our paper in March of 2025 for the live movies, there's a lot of links there. You can also email me. We have that paper is about 3,000 hours of live imaging.
Cool.
Wow.
We speed it up. I mean, it's like,
Oh no, I was really impressed.
yeah, I mean, it rivals Law and Order, I think, in the number of episodes that you could watch. But we're always happy to watch movies. We find that we were really focused on the epithelial cells. And then what's been great is that when you have a system like that, you can meet really, really interesting people who are working on other cell types and they see things differently,
Yeah.
right? So that's the other piece. And I would say, I think for clinicians who are listening, looking for resilience and being a treasure hunter, it's what I do every day at the bedside. So I think as a mom of kids, and my middle kid was in the hospital for about a week when he was a baby. He's better now. But we often come in and start with our problem list.
Mm-hmm.
And so I have a practice to start in, no matter how sick the baby is,
Yeah.
there's always something that's gone well overnight. Maybe it's just that they've maintained their temperature, right? But there's usually, the good news is that blood pressure looks good, or that they're moving around, or that, they tolerated feeds better. And then you can get to the problems. And I find a lot of times when I say that, whatever is happening in the ICU, it just time stops for them because there's a lot to celebrate, right? For a NICU baby, every day is a gift. So I think it's training ourselves to look for the things that are going well it's helpful in the lab, but it's really helpful at the bedside.
Oh, I love
I
that.
love that. How beautiful. I mean, the data really shows that the NICU admission makes families feel like their babies are not resilient when they're anything but. That's how they get home, is because they are resilient. And I just think that's so beautiful. And it's making me think about lung cells in a totally different
Yeah,
way.
I really
as well.
appreciated how you just
Yeah.
described cell biology to us.
In a way that we got it.
Yeah.
And I don't want the sped up version. I'd like to have it on my computer, come back in a few hours. and see.
Anytime. Happy to show any movies.
I love that. I loved your description about how this has shifted the way you talk to families. I wonder specifically when you talk to families about BPD, how do you describe it for them?
So at least what I would say right now is the way we talk about BPD in general is it's one
Entity.
diagnosis.
Yeah.
but it's a lot of different. I never know whether the word phenotype or endotype is right,
Right.
but we'll whatever the convention is of the incubator, we can use that. There's many different types. We'll just
We kept
types.
using phenotype, but I'm not sure that's right either.
We'll say types. We'll
Yeah.
say types.
My colleague is a loves to talk about BPD, so we talk all the time.
I think it's important both from a research standpoint, but again also as clinicians, that shared mental model of what is happening is so important. So right now it's a disease defined by a baby being on respiratory support, but you can be on respiratory support because you have a lot of malacia, or you can have lower airway obstruction, or you can have not enough units of gas exchange, or you can have pulmonary hypertension. And I always say babies don't follow multiple choice rules. They can have
More.
1, 2,
A,
3.
C, D, E.
They can have all of the above. They can have some of the above. They can have some of the above, but in a moment of desaturation, maybe it's only one of those things. And so this is where I think being thoughtful about physiology, going to the bedside, looking at the ventilator, looking at the baby, seeing what they need, and not necessarily always applying, well, here is our protocol for how we do this. And I think, so when I talk to families, I say, look, there's lots of, we sort of make that diagnosis at 36 weeks, but nothing really is different from the day before or the day after. It's not, if a baby came off all respiratory support at 35 and 4, I don't think we would
We
say,
know happens all over the country, right? We're just turning them down at 35.
we wouldn't say, oh, we fixed it, right?
Yeah.
To me, that I think there's an appreciation that the lungs are a vulnerable organ, but there's also a lot of hope. Alveologenesis happens in humans through early adolescence. And there's lots of things we know that can grow new lung. So nutrition, not having infections, not that it's your fault, but if there's ways to minimize that. So infection-free, good nutrition. And then we know from healthy kids, kids who do aerobic exercise, swimmers have bigger lung capacity than non-swimmers when they're twins. So when that kid is older, that kid should be playing sports. I always say, don't hold them back. Let them run around.
Which some parents have, we know through vulnerable child syndrome, some parents have the inclination to protect them, quote unquote, from some of those things when it may be exactly what they need.
Yeah,
Wow.
exactly. So I would say I think there is a way where our expectations often change what can happen. So if you think, if you think a student is going to be brilliant, they will probably be brilliant. If you think someone is going to be friendly, they will be friendly. I always say as parents, I don't want your baby's trajectory to be limited by my expectations. And there's a really nice paper, which the reference I am blanking on, I think it's in one of the JAMA journals, where they have a BPD bundle that really reduced the incidence of BPD. And there's a statement in the abstract, which I will maybe get the quote a little bit wrong, but the gist of it was the biggest barrier to overcome was the widespread belief among all the caregivers that BPD in this extremely preterm population was inevitable. But what if it wasn't, right? So I think some of it will be envisioning a world without BPD and not say, oh, well, they're 24 weeks.
So they're definitely going to have it.
Right. So, and I think we should always root for the baby. They will surprise you. There's no slides here, but I would say there's a baby who went home with a trach, and I get updates all the time.
I just got one this morning.
He's talking.
Yeah.
He's
incredible.
He's amazing, and that was not an easy path. But I think we should be realistic, but also I would say create hope.
Allow for hope.
For parents, but for us too. Right?
Yeah.
So they will surprise you.
Oof, what an inspiring
I know.
interview.
I love that.
Feeling very inspired.
I
And
think
talking
that's
about PPD doesn't always lead me that way. So
You can come do cell biology anytime.
I think that's the perfect take home message. Thank you so much, Dr. Sucre, for your work.
Thanks for having me.